Okay, so in this fifth lesson, we're going to look at some of the issues that arise when we find the area underneath a curve using integration. So, I'm going to go straight into an example here. This is our equation, and we want to find the area between this curve and the x-axis. So, first of all, we need to find our limits of integration. Well, the easiest thing to do is to draw a sketch. So, we can see from this that this is an x cubed graph. Something of about that shape. So what we need to do is we need to work out where does it cross the x-axis. Now we know that it crosses the x-axis when its y value is 0. So when y is equal to 0, what does x have to be? Well, we've got three terms here which are all being multiplied together, and we need to get an answer of 0. And we can see that if x is equal to 0, then we've multiplied by 0 and we will get an answer for 0 here. So we know that one of the values where it will cross the x-axis is where x is equal to 0. If we look at this one here, to make this bracket equal to 0, we need to say that, well, it's when x is equal to 2. 2 minus 2 is 0, that bracket is 0. So our second value for where it crosses the x-axis is when x is equal to 2. And our third one here is when x is equal to negative 2. So it's going to cross here, here, and here. So at negative 2, 0, and 2. And the curve is going to go up like that, like that. So what we need to do is we need to integrate between negative 2 and positive 2. Okay. Forward rubber. So our limits of integration is going from negative 2 up to 2. This is going to find us our area. Now first of all what we need to do is expand those brackets. So if I just expand the two brackets with the 2's in at the moment, x times x is x squared. You can actually see that when we expand this out, those two terms are going to cancel, so we're going to have just minus 4. So this is a difference of 2 squares sort of thing. And then if I just expand out to multiply everything by x, we're going to have x cubed minus 4x, integrating with respect to x. Okay, so now let's actually do the integration. Put our square brackets in to show that we have now integrated. X to the power of 4 over 4 minus 4x squared over 2, between negative 2 and 2. And we can simplify this just a little bit. We've still got x to the power of 4 over 4 minus 2x squared. And we're doing that between negative 2 and 2. Okay, so now what we need to do is substitute in our two values, x is equal to 2 and x is equal to negative 2. So, let's put our first value for 2 into this expression here. So we're going to have 2 to the power of 4 over 4 minus 2 times 2 squared. And then we're going to minus from that, I'm going to use lots of brackets here, negative 2 all squared over 4 minus 2 times negative 2 squared. Okay, well, let's just have a look at this before we go any further. Because negative 2 to the power of 4, well, that's just going to be the same as what we get when we do 2 to the power of 4, because it's going to end up being positive. And then negative 2 squared, well, that's just going to give us the same as 2 squared, because it's going to become positive anyway. So actually, what this is going to give us is this. When you minus it from that, will give us 0. And this term, when we minus it from here, will also give us 0. And we get an area of 0. But when I drew that picture before, the sketch of the graph, that had an area. So something's going on here. have a look at that picture again. Here's our x cubed graph. And what we've got is an area in here and an area in here. But when we integrated it, it found that that area here was positive, and this area here, because it's underneath the x-axis, it came out as negative. And so actually what happened was these two areas cancelled out and gave us an area of 0. Now, we can see that the area is not 0. So what we need to do is we need to be a little bit more clever about this. What we're going to do is this. We are going to draw the sketch that we've already done. We're going to label the regions, A and B or something like that. And then we're going to find the area of each region separately and then add them together. So that even if we get out that an area is 0, we're going to say, well, the size of that area is still positive. The negative sign is just telling us where it is. So we're going to say, well, even if the area is negative, we're going to say when we add them together, we're going to make it positive so that then we find the total area. So what we need to do here, well, from our sketch, and I'll put it on the next slide, I think. From our sketch, sorry, drawing it for the third time now. We need to integrate between -2 and 0, and 0 and 2. So we're going to do it twice. So the area, and let's just remember what that was when we expanded it out. That gave us x to the power of 3 minus 4x squared. Is it just 4x? Yes, it was just 4x, sorry. dx. Okay, so when we find the area separately, the area of region 1, I'm going to call this one region 1. Well, that's going to be the area, and we're going to integrate it from -2 up to 0. And that's going to be of x cubed minus 4x dx. And then we are separately going to find the area of 2. And this here would be the area of 2. Area of 2 is going to go from 0 up to 2 of x cubed minus 4x dx. Okay, so we need to do our integration. It's going to jump straight to what we know it already is, x squared, and that's going to be from -2 up to 0. And the area of 2 is the same thing, and the only difference is the limits, 0 up to 2. Now here, we're going to substitute in the 0, well that's just going to give us 0. And now we're going to substitute in the -2. So that's our -2 to the power of 4, all over 4, minus 2, -2 all squared. Okay, and we're actually going to work it out this time. So, -2 to the power of 4, well we know it's going to be positive, so that's going to give us 16 over 4, which is just 4. Now, -2 to the power of 2 is positive 4, times it by -2, then we get -8. Now, 4 minus 8 is -4, but all of that has a negative in front of it, so we're going to get an area of 4. And that's what we would expect. We would expect to have a positive area for region 1 because it's above the x-axis. Now let's do the second side, and you can probably guess what this is going to give us. Let's substitute in the 2, 2 to the power of 4 over 4, minus 2 multiplied by 2 squared, minus 0 for our other limit. So 16 over 4 is just 4, minus 8. And we're going to get a final answer for the second region of -4. Again, you probably could have predicted that. So, the total size of the area is just going to be 4 add 4, which is equal to 8 units squared. So words of wisdom. And I think these questions we're going to need to do in class so that I can give you a hand with them, just in case anything goes wrong. But these are the words of wisdom that you need to keep in mind. So when finding the area under a curve, draw a sketch first to see if there are any negative areas. Find each of the area sections individually so that you ensure you find the total positive area, so the total size of the area. Okay, and I think that's the end of lesson 5.